Hi guys, welcome back to my blog. So if you've known me, you'd know that I'd like to work on biology or engineering related projects. And one thing about biology projects is that they require tools that are really expensive and hard to find. So I actually innovated a bunch of my own homemade tools in somewhat of a homemade lab situation, and I'd like to share them, and maybe if you're trying to get into something biology related, you can, take some ideas. So one thing you're gonna need is a Bunsen burner. And a Bunsen burner is basically this tool that emits fire to kill or burn bacteria for sterilizing like glass rods or the tips of tubes. So here with me, I've got a camping stove. And as you can see here, just by turning it and igniting it, it emits a really hot flame, which I think could pretty much be used as a Bunsen burner. Next, you're gonna need a vortex mixer. And the vortex mixer is basically this tool that mixes vials and tubes and beakers at a really high speed. So here I've got a PC fan, and connected to it is a cup, which is a little bit off-centered. And by making it a bit off-centered, you can pretty much allow yourself to have the exact same functions as a regular vortex mixer with exact same vibrations, shaking. It'll just save you maybe like 120 bucks. Now, another really big part of your project is going to be an incubator. And an incubator is what's going to be essential for making sure that your bacteria that you're cultivating maintains to grow at its optimal temperature. For example, some bacteria grow at very specific temperature ranges, most specifically like 37 degrees Celsius. So here, I'm going to show you, I'm going to have to move the camera. This is where the magic happens. So this is my homemade incubator, and this is a Raspberry Pi which regulates all the functions. This relay right here is what controls this light bulb, which is the heating element. And if you can see inside here, there's a little temperature sensor right there, and my bacteria, which is cultivating right now. And when that temperature sensor goes above or below a specific range, it makes a signal to the Raspberry Pi, which allows it to turn on and off the light bulb, which either heats or lets the temperature go down by cooling. Now, if you're going to be working on a project that has bacteria in the liquid form, in like a vial, for example, you're going to need a shaker. And shaking water baths are very expensive, so I came up with a solution of my own. By placing the bacteria in the incubator, it allows it to maintain its optimal temperature. But then there's the shaking problem. So, here is a little Lego setup I made, and there's this motor here, a Lego motor, which allows this little shaking mechanism to happen from circular to linear motion. And here's what makes my project special. I've got a solenoid coil, and here's the ferromagnetic shield, and basically, the vial that's going to sit in this solenoid is the bacteria that's going to be getting exposed to the magnetic fields. And in here will be the control bacteria where no magnetic fields are going to be reaching it. And using that, I can measure the differences in bacteria that gets influenced by magnetic fields and bacteria that doesn't get influenced by magnetic fields. Here is a controller which allows me to control the magnetic intensity of the coil. It'll maybe have it less or more microtesla. And here is a frequency generator, which I can use to control the frequency of the waveform that I'm going to be using on the magnetic field, on the magnetic coil. And I can also control its amplitude and voltage, so from 0 to 20 volts. Finally, I want to show my optical density meter. So optical density meters are really, really expensive, but I found a way to 3D print one and make them a whole lot cheaper. So here is the actual device itself. It's really just a 3D printed shell. And in here, this is where a light will go through, which is pretty much an LED from my Raspberry Pi. And out here, where it'll be where the sensor, the light sensor, the lux meter, and it'll measure how much light gets, passed through. And this is a cuvette. And in here, I'll put my bacteria. The cuvette just slides right in here into the optical density meter. And then it can actually, read how much light is coming in versus how much light is getting passed out. And using this, I can basically measure really the optical density of the bacteria within the liquid culture. And I can get more into this in my other videos, or if you want, you can research this more on your own. But this is pretty much a lifesaver. So I might link this later in a description or so, but this is an optical density meter, which has been 3D printed. Overall, there are many ways to bypass the limits placed on you by not having access to all of these scientific grade tools. So this is hopefully an inspiration to tell you to not let a lack of resources stop you from pursuing what you love. And if you want, I can get more videos into showing really how to make all of these different tools, because all of these have pretty much saved me so much time and money, and I would love to share it with the world. So thank you for watching my blog.